Hi everyone, this is the Get in My Garden podcast. I'm Aaron Moskowitz, and today we learn about the soil food web, what exactly it is, and then we explore some of the basics of fungi in the environment and how plants interact with them. This is episode 63, and we talk with Casey Ernst and Keisha Wheeler of Catalyst Bioamendments, a composting and soil company they run with business partners Zach Ellis and Gregory Munn in Northern California. Follow their adventures on Instagram at catalyst_microbe_adventure. Another thing that is finally taking shape, as I've mentioned, is the newsletter. It will include a synopsis of each podcast, that supplemental content I've been promising for a very long time, bios and info about the guest experts and their work, and then highlight posts from the Facebook group I created called Soil Balance with microbes, minerals, fungi, fertilizers, and bugs, and it will evolve to so much more. You can still sign up on getinmygarden.com in the yellow newsletter bar, or if you're not yet a member of the Facebook group, search for that group starting with Soil Balance, then enter your email where it asks for it when you first sign up. Also reach out to me via the website or Instagram, getinmygarden.com and at getinmygarden.
I'm Casey. I got interested in the whole soil food web by, actually it was like reading Jeff Lowenfield's book, Teaming with Microbes, and Elaine does the forward in that. That's the gateway drug, I feel like, to the whole soil food web revolution going on. When you're talking about the soil food web, the web itself is a mixture of bacteria, fungi, protozoa, which come in the form of flagellates and amoeba. And then you're also looking at your higher trophic levels of animals like nematodes. And then you get into microarthropods as well. But that web is basically that interaction, that community of all of those things working together to take organic materials, to take minerals that are existent in the soil and turn that into plant available foods. So also the plant as well is incorporated into that whole web. The plant takes sunlight, it turns it into sugar, it sends it down into its root zones, and it feeds the microorganisms that in turn take that sugar and then go and get nutrients and bring it back to the plant.
When you look through the microscope, do you see new components that you can't recognize? Is it hard to find out exactly what they are sometimes?
So yeah, we do everything that we do is based off of morphology. So it's basically based off of how it looks, what it looks like. And, you know, it's like exploring space. Every single time you put your nose in a microscope, you're going to find something that possibly nobody has ever seen before. But whether or not it is necessarily that you need to know what it is exactly isn't the most necessary thing. You know, we're looking for certain groups of things that we know do certain functions, and then you're always going to find new stuff all the time.
Yeah, it's totally fascinating. I've watched some of the groups on Facebook, what people are posting, and sometimes people can't really, it takes a long time to identify some things.
Yeah, for sure.
So you're counting things, and would you basically be making kind of like a spreadsheet to understand like what percentage of certain things are in there to get an idea of whether it's working properly?
So the way we do our work is it's based on the idea of like population statistics. So we're going through a sample and we're looking at, I mean, when we pull out a gram of soil, we're looking at individual drops of that 1 gram. So it's like the fraction rate of that is like up to 2,000. It's 2,000 drops per 1 gram of soil. So we're really looking at these minute spaces. And so we're using kind of a population statistic to get a general idea of the amount of each individual group is in the soil.
Okay. Yeah, for sure. And the thing that people might not realize that I think is so great is a lot of people are trained to just go to the store and buy something and put it in, but that's not how the soil food web works. You're building up the soil. So if you're building from nothing and you see that there's some component missing, what are some of the techniques that you use? I mean, obviously composting, but does that process just work naturally?
Yeah, I mean, it's kind of the idea of like, if you build it, they will come, you know, like a lot of these, like, especially like fungal spores, they're in the air everywhere around us. They're floating around, just waiting to land in a place that they can grow out and start thriving. So yeah, when we look at a soil and we see something's missing, you know, if the soil food web isn't there, that's the time where you do need to supplement food because the plant's not getting the nutrients that it needs. But we like to keep those to a minimum. We do not like to overfeed, you know, so.
One of the best fungal foods is actually plants deliver that to the soil. So when you look at plants that are in a higher trophic level, that, you know, mid-level grasses, most of the foods we eat, tomatoes, pumpkins, watermelon, all of those plants actually deliver a fungal food directly to the soil to exchange with the fungi for nutrients. So I did talk about wood chips being a great fungal food earlier, or peanut shells, oats. There's all kinds, but really a great fungal food is what the tree puts out or what a plant puts out into the soil. So to remember that the plants are really the part of the system that is driving a lot of the commerce. They're doing business in the soil. The plants and the microbes work together. So just always remembering that is the interaction that's going on, and there is no better fungal food than what the plant's going to feed it.
That makes sense. So the plant, they know what they need. So they put out these, naturally occurring fungi that are on their, I guess, on the plant, right? And then it falls to the soil, and then it builds the soil food web. Is that right?
More or less, anything that's in its root zone, in the rhizosphere, it's going to interact with and can interact with. When we bring in the compost, often we're introducing new species of fungi. Like Casey said, there's spores of life everywhere. And by creating a compost with as many different ingredients as possible, those microorganisms are laying on the surfaces of that plant material. So when we bring in really, really diverse materials, organic materials, it's just kind of bringing together this larger and larger and larger, more diverse group of microorganisms. So we're introducing new guys to the soil. And then there's also, bees carry around spores on their little feet. And there's more than just pollination going on whenever insects move around. So kind of honoring the entire food web. Birds carry microbes, insects carry microbes. There's so many ways for things to move around, but that's also what we're doing with the compost, is really specifically adding a more diverse group of characters to the root zone so the plant can work with them.
Thanks for listening. Follow my adventures on Instagram at Get In My Garden. Send me a message there or on my website. I love hearing suggestions about your projects, hobbies, and interests. Next week, we have more about the farmers marketeer lifestyle and some new information from the amazing world of mycology.